Okay, for tutorial 1, okay, some discussion on it where you will have a basic requirement of the communication system. We have 4 basic requirement. It's about the rate of information transfer, how fast the information can be transferred, and then the purity of the signal received, whether the signal received is the same as the signal being transmitted. And number 3 is about the simplicity of the system, whether it is a complex or simpler system, and in terms of the reliability, how the system can be connected. Okay, so that are the basic requirements. So describe 4 elements of communication system based on this figure where you have the information as the input, the transmitter, the channel, and also the receiver part. Okay, so we need to describe all of that stages to the element. Question number 3, you need to calculate the total power of the given signal. So that signal is given in a dBm value. So convert each signal to watt or milliwatt, then add them together. Okay, and then convert back the value, the total value, to the decibel. So you get the total power is about 5.12 dBm. What is the limitation in a communication system? You have either the technological problem or the physical limitation. So the technological problem will involve all the issues with the equipment availability, the economic factor, the regulation, and others. Okay, so the physical limitation will be based on either you have a bandwidth limitation or the noise limitation. So define the modulation, why modulation is needed in a communication system. So you have to know what is a modulation itself and what are the purpose of that modulation technique. So why we need that in a communication system. What is meant by the term of a bandwidth? Okay, so what is bandwidth? Which means that it is a range, okay, for the specified spectrum. List down the range of frequency and bandwidth for the AM broadcasting, FM broadcasting, and TV broadcasting. So this one you can refer to any of the textbooks or in the notes where we'll have a TV broadcasting. It will be depends on this VHF and UHF in general. Okay, so explain 2 main categories of noise, either internal or external noise. So you can elaborate a little bit on that type of noise. Calculate the wavelength in a free space corresponding to this given frequency: 1 MHz, 27 MHz, and 4 GHz. So the wavelength, which is the lambda, is equals to C over F. F is the given frequency here. C is the speed of light, 3 times power of 8 meter per second. Okay, so you calculate the lambda, then you will get this value. Question number 9, the receiver system have 3 stages comprised of 2 amplifier and 1 filter. So calculate the input power in dBm and the total gain. This one is just simply converting the input power to the dBm value and calculate the total gain, okay, for each for the total for each stages, and then calculate the output power in watt and also in dBm. So we know that the gain is the ratio between P out and also P in. So now we have the value of the gain and also the P in. Okay, so calculate P out. What we'll get in terms of watt and then convert that to the dBm value. So the dB gain for each of the 3 stages and the overall gain in dB. Once you have the value, the decibel value for each stage, then can add all together to find the total gain, or you can simply convert from here, the one that you get from the first equation. Given a 3-stage system with an input power minus 26 dBm and the power gain for each of the stages also given in the decibel value, so determine the output power in dBm and also in watt. So the total gain can add all these stages, so you get the total gain, and then we have the output power, just simply addition of this minus P in plus the total, then you will get the output. So the output in term of watt will be 10 to the power of milliwatt.